Real estate investment practice problem using Excel. Points break even point using a pivot table part 2. Get ready because we're raising the stakes with real estate. Here we are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, note that we have 3 tabs on down below: example, practice, and blank. Let's take a look at them now, starting out with the example tab, in essence being an answer key. Focusing in on the points once again, but this time we want to use our pivot table to do some of the analysis with regards to points, as opposed to copying and pasting the entire worksheet as we have seen in prior presentations, this possibly being a little bit easier and possibly allowing us to do projections a little bit more quickly. So we have our information that will be up top. We're going to be adding then the information related to the points so we can do the calculation. That will then feed into our pivot, our normal amortization table with 360 periods. Then we will create a pivot table. We can create the pivot table with either 360 months, or we can create it with the years here and just have the 30 years on the pivot table, which will give us the estimated data for us to calculate the break-even amount and then get an estimate on the IRR amounts that will give us a good idea of comparisons between different loan amounts. Remember, when we're looking at whether or not we should be paying down the rate, as they say, buying points, the question is oftentimes, how long are we going to have the loan outstanding? And if we know how long the loan will be outstanding, then we might want to compare the internal rate of returns, in essence, the effective rate, and or we might be looking for the point at which the break-even will happen, the time frame where buying points or not buying points will basically be a wash or be a break-even point is a common starting area to look for. So that's what we will be doing. If we look at the practice tab here, then we have the blank area where we're going to be entering data. And so you can have the blank area here that's pre-formatted, making it a little bit easier to work along with the practice problem. And then in the blank tab, we'll be creating everything from scratch, starting it from the starting point. So let's add this. I'm going to add the first point fairly quickly because we've seen this in the past. We got our same starting data, loan amount, the years, the months, and then the rate. And then we're going to add our points category. Once again, we've seen this a couple times, so I'm going to do it a little bit more quickly. We're going to add a points field and say we can have 1 to 3 points oftentimes. Then we're going to say what's going to be the rate decrease per points. How much will the rate go down per point? Per point. And we're going to say 0.0025. Adding a percent, number group percentifying, adding a few decimals. That's 0.25% or 0.0025. We got the point fees, so the fees for the points. And it's going to, a point means 1% of the loan amount. So each point is worth 1% of the loan amount. Let's do that with a formula. Equals the 200,000 times the points, which is 1. And then I got to multiply that times 0.01 to make it 1%, which would be the 2,000. If I change the points to 2, 4,000. Changing the points to 3, we get the 6,000. That looks correct. If we take the rate after the points, so where will we be if we pay down the rate? Where will we be if we bought 3 points, each point bringing down 0.25? We should be at 5 minus 0.25 times 3, or 0.75, which would equal 4.25. Let's try to do that with a formula. This equals then the 5% minus the 0.25 times the number of points, which is 3. Making that a percent, number group, percentifying it, adding a couple decimals. We're at the 0.25. That looks correct. You want to double check that your payment here is picking up the proper percent field after the points have been calculated. And also make sure that your table is picking up the proper field in terms of interest rate, which is after the points have been calculated as well. Then we can calculate the effective rate. This is the one that we can compare and contrast between other loans, combining in the cost of the points, the upfront cost, and the interest rates into one number so that we can then make comparisons with other loans. So we're going to do that here and call that the effective rate. This would be like the IRR, internal rate of return, for the whole 360 period kind of idea, equal to the rate the rate formula, brackets, we're going to be picking up the number of periods, which is going to be 360, comma, the payment, which is going to be this calculation down here, the 983.88. That needs to be a negative, or else it won't work right. And then comma, we've got the present value, which is going to be the loan amount. But we got the twist, it's the loan amount. If we just use the loan amount and then multiplied times 12, we'd get back to the 4.25. But we're going to take that times, or plus, minus the 6,000. So we really got 200,000 that we used to purchase the home, minus we paid to the loan company another 6,000, closing that up to pay down the rate or buy the points. That's why we paid the 6,000. And then multiplying this times 12, because that would give us the monthly rate. We want the yearly rate, so we multiply it times 12, add, percentagize it, number group, adding a couple decimals, we're at the 4.508. So that populates our amortization table. Make sure your amortization table is picking up the proper interest rate, which should be that 4.25. Notice we still start off up top in the amortization table with the 200,000, even though we bought the points and really the cash flow up front was the 200,000 minus the 6,000. That's where the confusion kind of comes in terms of what the actual cost of the loan is. And if I go all the way down to the bottom, double check that your loan does indeed calculate out to be 0 at the bottom. Double checking that we have the proper calculation in terms of the loan. Now we're going to add a pivot table. We've done this in the past. We'll do it fairly quickly here. If you want to do a slow pivot table calculation, take a look at prior presentations. We're going to go and make sure we're inside the table. Go to our Insert tab up top and Pivot Table, Pivot Tabs, and then there's our pivot table. I'm going to put my cursor on the existing worksheet and put the location. The location is going to be in K1. K1 at the location and OK. So there's our pivot table information. We're going to take the years. Now note that you could build your pivot table with the months, which we haven't done so much in the past, but you just do the same thing, months, bring that over. That would give you your 360 months. And then you could do the same alterations. That will allow you to kind of adjust the pivot table and just copy and paste the data from the pivot table using the 360 months. However, you might want to say, well, can I estimate this stuff with years maybe, so that that'll allow me to do it a little bit more quickly and not have to work with such a long amortization table? We can try that. We're going to say the years here. We're going to say payments, interest, loan, and the balance. Format those cells by hitting the drop down on down below, value field settings. We're going to number format that. Make that then currency, brackets, take away the $sign, remove the pennies. Okay, we're going to hit the drop down again on the next one, value field settings, number format, currency, brackets. We're going to take away the $sign, remove the pennies. Okay. Next one, drop down, and it goes up, drop up, field, number format, currency, brackets, remove the $sign, get rid of the pennies. One more time, a little bit different, bit of a twist on the last one, you'll recall from prior pivot table. We're not doing the sum here because this is the loan balance. We want the minimum amount, which would be the amount at the end of the year. Then we're going to number format it. Currency, brackets, $sign, gone, no pennies. Okay, and okay. And then that looks good. Let's do some formatting here, standard formatting, so we can make it fancy. We're going to go to the Home tab up top. Let's put some borders around it, borderize it like so. Let's make it bold. Let's go to our headers and make that our black and white thing up top, which is like our usual thing. Let's wrap the text. Let's center it. Let's double center this one. And let's squish up the columns. Squish. Columns. There we go. That looks better. All right. So now that we have that, we can then do our comparison, comparing points to no points, while we just think about the 30 years and kind of group our information together on a yearly basis, even though the payments are actually being made on a monthly basis, which will be an approximation but it might give us what we need in order to do calculations a little bit easier. So let's squish this up. Let's first calculate that break-even point again. So the points break-even point. Now, when we do the break-even point and we're switching back and forth now, instead of having two sets of data, I can't use the formulas as much. I have to hard code the number a little bit more. So this will be a little bit different than the prior presentations. These are some of the pros and cons of the different formats you can use to analyze this kind of stuff. So we're going to go to the Home tab, Font Group, black and white on the heading. And then we're going to say the cost of the points, cost of points. Now, if I say 3 points over here, the cost would be 6,000. I would like to reference that 6,000 with a formula, but I can't, because if I do that and then change the data, it will not. Those points will be gone. So I'm just going to manually type in here the 6,000. We call that hard coding it. Just hard code it in there. The difference in payments is going to be the payments without points. Payments without points. And so if I remove the points to get that number, we're going to go over here and say, what if I had no points, 0 on the points? Then the payment would be that 1073.64 about. Rounding is involved, so 1074 we'll just say. 1074. And then payment with points. Now I got to add the points back in so I can see the payment with points. Let's say 3 points. Payment, then the 984 about. So we'll just use the 984 for rounding. 984, underline, and that's going to give us our difference in payments. Subtracting that out. This is our standard calculation for the points. So we will indent this one again and then indent it here, make it a little bit more fancy looking. Easier on the eye. My eye likes the thing that are easy on it. Points. My eyes have had a tough day. Got to keep it easy on the eyes. And then we will then divide this out. That means 6,000 cost divided by the difference in payments. So the difference would make up that 6,000 cost in 67 months about. Let's underline this. And if we want to see that in years, let's say points break even in years, that would be equal to the 67 divided by 12. Let's add a couple decimals, number group, couple decimals, about 5.5 years that we would have. Let's go ahead and bluify this. Go into the font group, borders, bucket, and then make it blue. So there we have it. Now, notice in the prior presentation, we pointed out that basically this number gives you a general idea that prior, if you're going to sell the home prior to that, then it might not be worthwhile to buy the points. If it's after that, then it might be more worthwhile to buy the points. It's possibly more accurate to get the effective rate as of that point in time, which would be the IRR type of rate. And it might be, a little bit different if you look at basically the actual effective rate than this number, due to the fact that you've got those ending balances are going to be different. So when you sell the home, you'd have to pay off the loan, which is going to be different due to the two different rates as you calculate it. So it's possibly a little bit more confusing than that. But notice that if you knew when you were going to sell the home, you're saying, I'm going to sell it in 5 years or something like that, then you can calculate the IRR in essence for that time period, and or you can use the internal rate of return, and then you can do the comparison between the two, assuming that you took out a 30-year loan and then assume to sell it after 5 years or something like that. So now when we do that, then if we do it on a month-by-month basis, as we saw last time, we'll get a more accurate number, but we're dealing with large amortization tables. You might be able to do the same kind of internal rate of return calculation with your pivot tables, or possibly use the pivot table in the format of months so that you could just use one amortization table and just change your data, back and forth from that table or something like that. So we're going to use the yearly pivot table and kind of figure out what the IRR would be, just to get an idea of the internal rate of return. So we're going to say this is going to be points, and we're going to say this is the cash flow. Let's go ahead and center those, alignment and center. We're going to say bucket. Let's make it black and white. Let's wrap the text, and we're going to take this from period 0, 1, 2. Now let's start off by taking it out to 6, because that would be rounding up to 6 years here. So we're then going to center that, alignment and center. And the cash flow that would happen if we're talking about the points would be the 200,000 that we would get minus the points that we paid, which would be 6,000 in points. Again, I'm going to hard code it in here. I'm not going to use formulas because I want to change my data set table to bounce back and forth from having points and not having them. So I'm going to take the 200,000 minus the 6,000, and there's our 194, and then we're going to have payments that happen each period of the 11,807. Now those payments happen monthly, but we're going to assume that they happen yearly for simplification. In other words, it's going to be that 983.88 times 12. It's going to give us the payments that we will make on a monthly basis, but in total for each year, the 11,708. Our calculation will be a little bit off due to the fact that now we're assuming, these calculations assume the payments happen at the end of the period, which would be the end of the year instead of at the end of each month. So it's an approximation. It's going to be the 11,807. Let's copy that down. Copy that down like so. And then this last one on the last period here will then be the loan balance we would have to pay off if we sold it, plus we'd have that last payment. So we'd have the last payment, and then we're going to assume we pay the last payments, and we have the loan balance that we got to pay off. So there's double cash flow here. Negative, I can't use a formula. Let's do it. It's going to be negative the 11807 minus the balance, which is that right there, 177447. So there we have that. Now, if I was to total that up, total cash flow equals the sum of these items. Let's put an underline here, font group and underline. We can calculate the IRR. The equals, no one calls it the because it sounds funny, but you would think it'd be an easy way to see. The equals the IRR, shift 9, internal rate of return. And let's make that a percent, add a couple decimals. And so there we have that. Now notice I didn't have to multiply it times 12 because now we're in years. Last time we did this, we had to deal with the fact that we were doing months to years. So we come up to 4.83. Now notice you would think it would be closer to 5, right? You would think it would be closer to 5 because we're trying to compare it to with no points, and with no points, it would be at, you would think 5 right there. So you might say, that's pretty close. That's kind of what they gave us on the IRR, but let's, instead of rounding up to here, let's bring it back to 5. And the difference may not just be because of the rounding here between the years. It's because this calculation here isn't taking into consideration exactly the difference in the balances. So this is kind of an approximation calculation. But we'll do the same thing over here. We'll say, okay, well, what if I took this and we said that this is going to be 0, 1, 2, but now we're just going to take it down to 5 periods, 5 years, center that. Same cash flows. So I'm just going to say equals this cash flow, but then it's only going to go down to 4. And then I'll take the ending balance at the end of year 5, which would be this amount, that amount. That's how much we'd have to pay down on the loan at the end of that time frame, 181615 minus the payment that we'd also be making, 11,807, which would be 12 payments adding up to 11,807. So that would be the 193,422. If we total that up, let's total it down here so the totals line up, equals the sum of these items, and then the IRR The IRR, the internal rate of return, is going to be those, making that a percent number group, percentify it, and adding some decimals. So that's closer to 5%, right? So you would think that that would be a little bit more accurate because that would be closer to 5%, which is what you would expect if you had no points. So that's just another way you can kind of think about how this might work. Now, remember that if you're planning on selling it, like if your thought process is I'm going to hold on to this for 10 years, then you can calculate the IRR more specifically as of after 10 years. And that might be useful for you to do comparisons to other loans, right, that might have different breakouts with regards to their points and whatnot as of, so you're still taking out a 30-year loan, but now you're trying to figure out what it would be, basically the effective rate at a certain point, like 10 years, and possibly then comparing that to another loan. Whereas here, you're doing something is even a little bit more complex, trying to find that point at which you have that break-even point. So then let's just do, for comparison's sake, let's say that we had the same thing with no points. So we'll copy this up top and say no points. And then we'll have the same 0, 1, 2. And you would think this would come out to 5% with no points, but it'll be a little bit off due to the fact that we're using the years. We're rounding it in essence again. So we'll center that. And now I'm going to change my data and say, let's get rid of the points. Points gone. Refresh the table on the pivot table. So we'll refresh the table over here by right-clicking on it and refresh. So there we have that. And then we can just take our data and say, well, what if we had like no points? Then we'd have 200,000 and we wouldn't pay. That's how much we got up front that we then used to pay off the home. And then we had the payments that we're going to be making, which are for the full year 12,884. Those are 12 payments per year that add up to negative 12,884. That's a 0. 12,884. Fours and zeros are different. Let's copy that down. And then in year 5, we'd still have a loan balance, the loan balance that we'd have to pay off of 183,657. So we're going to say negative 183,657 minus the 12,884. Those two balances would be paid off at the end. And there we have it, the 1927 or 196,541. And then if I total that up, total and sum, we'll sum that up and then calculate the IRR equals the internal rate of return. And we make that percentify it, add a couple decimals. So we're not exactly at the 5%, which is kind of, you'd expect basically to be at the 5%. Now, if I subtract these two out, the difference between here and here, we've got a difference of the 1,427 in terms of just cash flow. So hopefully that gives us kind of an idea how we can use these tools basically on a yearly basis. And again, this comparison for the break even can be a little bit confusing. It can be maybe a little bit easier to kind of figure out exactly where the break even is on the internal rate of return calculation if you use something like this, a cash flow calculation. That last point, the balance is the confusing part. It might be easier for sometimes to look at it on a yearly basis, even though you're doing approximations to do so for that with the total year. But it might be enough to kind of get an idea of it. And again, if you're talking to someone that has a more concrete, or if you have a more concrete idea of exactly how long you plan on holding something, then you can calculate this internal rate of return a lot more easily. Instead of the break evens, you got to hunt for it a little bit. This is like the approximation kind of the break even, but you'd have to hunt. But if you know exactly what you're doing in terms of how long you expect to hold something and you're comparing different scenarios, then you could take out that 30-year loan and you could try to figure out the internal rate of return given that period of time, either on a yearly basis, which is an approximation, or using the total monthly period basis. Okay, let's go ahead and format this. Let's do some blue and border. The blue and border by going to the home and font group, border it, bucket, blue. And then blue and border this one, blue and border. Font group, brackets and border. And then we're going to say this one, brackets, no, it's blue and borders. Those aren't brackets, they're borders. And then the difference. And let's go ahead and blue and border that, blue and border. Font group, blue and border. Let's spell check it, see if I misspelled anything. I did, of course. That's okay. Points. So that's it.